Example 4. Let's sketch a graph of p of x. P of x has two pieces. When x is less than 1, I look like this parabola, 1 plus x squared. And when x is greater than or equal to 1, I look like this line, negative 2x plus 4. So I'll call that the left piece, the parabola shape, and I'll call the linear function the right piece. So if I'm looking at the parabola side of this piecewise function, y equals 1 plus x squared. I'm going to choose maybe 3 points, including the boundary point of x equals 1, where I know I'll have a hole. So I would start maybe at x equals negative 1, 0, and 1. And I plug in these values. I'm going to get 2 here for this. 0, I'll get 1, and at 1 I would get 2, but this would be the hole because on this left piece x is strictly less than 1, so I wouldn't exist on the boundary, so I'll designate that with a hole. So this would be the left piece, the parabola piece, and then the right piece will be a linear function, and it only takes 2 points to construct a line. So I'll start with the boundary x equals 1, and then I'm going to plug in negative 2 times the x value I choose, and then plus 4. So when I plug in 1, I get 2, and this will be a filled-in hole because I can be equal to 1 on this piece. And then let's just pick one more nice number. How about the number 2? And when I plug in 2, I get negative 2 times 2, which is negative 4, plus 4, I would get 0. So that's how we're going to sketch this graph, one piece at a time. I know the shape of parabola looks like this. I'm just going to end wherever I have this hole. So at negative 1, 2, and at 0, 1, but then at 1, 2, I have a hole. So, and I do stop there, but from the left, I'm the entire shape of the parabola, and I indicate that with an arrow on the left. And then x greater than or equal to 1, at 1, 2, I'd actually now fill in this hole because of the right piece. I am the point 1, 2, and then 2, 0. So from 1, 2 to 2, 0, I'll pass through the 2, 0 point and draw an arrow in the direction y goes to negative infinity and x goes to positive infinity. Part B, is P continuous on its domain? Well, yes, it actually is, because the right piece fills in the hole from the left piece. Okay, so we don't have to lift our pencil tracing the graph of this function now after it's complete. We would just draw on this line, never have to lift our pencil. So this piece is continuous, this function is continuous on its domain.